the record button. So here we are. We're going to try to work through a practice problem today. This is a problem that involves figuring out information such as wind and flight planning. It's going to be a little tricky because we're trying to use digital products. And just, for kicks, just kind of show you what's going on here. This would be like the old-fashioned physical hard copy that you'd want to use if possible.
Yes, sir.
And what you'd want to do is you'd want to try to line up your straight edge with the route that's in question. And just for kicks, just to kind of show you what's going on here. Not that you're probably gonna want to do this when on every single problem that comes up on the written exam. But I'm just going to kind of do it really quick and easy just to kind of give you an idea of what you need to do. And plus, when you're playing in your real cross countries, this is an exercise that you should be able to do. Unfortunately, this is an old skill that a lot of pilots probably don't really spend a whole lot of time with nowadays because of fancy technology like ForeFlight. But it is a skill that you should know how to do, how to, plan a flight using a piece of paper and a plotter. So for today's example, I've loaded this sucker up and I'm trying my best not to move it, but it's going to be a little tricky for me. But here, so at the very top of the, gosh, this is terrible. Okay, so I'm going to click back over here to the screen share so you can see what's going on. So here, up here is the Priest River Airport. Underneath my mouse, down here is the Shoshone County Airport underneath my mouse. And if I could draw on this screen, I will use a draw straight line. You got to imagine that your route of flight is going to, and my mouse is freezing. That's handy. Try again. What am I doing wrong? Draw, figure. Okay, let's try again. So I click. Okay, it's working. So you want to imagine that this is your route of flight. Just like that. That's what your route of flight is going to be. And then you got to imagine, I don't know if I can draw a perfect circle. I can. Ooh, look at that circle. Okay, so here's a circle. I've never done this before. Let's start here. Not quite. So here's a circle, if you imagine. I wonder if I can move it. So you imagine that you want to get your circle part of your plotter to align with this vertical. So you have these vertical and horizontal lines, lines of latitude, lines of longitude. And when you imagine this north and south line, that would be a line of longitude that runs from the North Pole to the South Pole. Okay, the lines of latitude that run east and west, you can use those lines as possible references, but you're actually better off to use the vertical lines, the lines of longitude, because every single line of longitude runs from the North Pole to the South Pole. So there's not so much distortion, because we're trying to put like this circular cylinder, circular sphere object called planet Earth onto a flat piece of paper for the map, for the chart. So you're actually better off to use the long lines that run north and south perfectly. So what I'm going to try to do, holding up my camera, and what I'm trying to do here, trying to show you for flight planning's sake, is that you're going to have a plotter, and you would like to line your plotter perfectly up so that way the long ruler called your plotter has an imaginary line just like this line between your airports, between Priest River and Shoshone. And in the center of your plotter, there's a circular piece of it, and it's not a perfect circle on the screen, but you want to get your circular portion of your plotter to align with the hole in the center, the grommet, the hole in the center of the circle, that grommet. You would like that line to be underneath a reference line of some sort. You would prefer a north-south reference line called line of longitude, although if you, in a pinch, if it wasn't available, you could use an east or westerly line of latitude. However, there's more errors associated with that because of the distortion of putting a circle onto a flat piece of paper. Goodness. Okay, so I'm explaining to you that there are multiple types of plotters. I personally today have a plotter that rotates. Can you tell me, do you have a plotter that rotates or do you have a plotter that's fixed?
I have a fixed plotter.
Okay, so on my plotter that rotates, I will actually spin the wheel and I will align perfect north on my wheel with this up and down line of longitude. With you, since your plotter does not rotate, what you will do is you will reference this north and south line of longitude, and instead of rotating anything you can't rotate, you will read inside, you'll read the inner portions of the circle to try to figure out what degree angle this might be. And there'll have to be some common sense with it because the plotter doesn't rotate, so it doesn't know if you're lining up north, south, east, or west, or what have you. So you'll have to line it up and then use some common sense as to which scale is appropriate to align with the flight. So I'm walking you through the whole setup here, and just so we're all on the same page, let's kind of go backwards and reimagine what our question is. We're trying to figure out the magnetic heading for a flight from Priest River Airport 1 to Shoshone County Airport Area 3, and then we're going to do winds. So what I would really communicate to you is that we have a lot of information that's already written out to us that is on our plotter. So my plotter is really old. It's not the best one, but like when I look at like the back of my plotter, there are instructions that are written up top. There are instructions that are written down below. It really just kind of depends on what kind of plotter you are actually using. Yes, and you're going to find instructions on there somewhere. Now, sometimes they don't actually spell out every single word, vocabulary word, because it's a small fixed amount of space. So sometimes they might use like, abbreviations. Like they might say TH. TH might mean true heading. They might use TC. TC might stand for true course. They might use WCA. WCA would be wind correction angle. They might use MH, magnetic heading. They might use TH, true heading. They might use VAR, variation. CH would be like compass heading. MH would be like magnetic heading. DEV would be like deviation. So just depending on what product you have, you might see some of those. They're not acronyms, but abbreviations. Are you seeing any of that on the back of your plotter?
Yes, sir. I see it. I see it right underneath the instructions.
Yeah, so I called it the plotter. I should actually call that the E6B whiz wheel. So I'm just kind of framing the whole process to you. So as you become better at flight planning, you have an idea of what's going on and what we're doing. Okay, so let's start with some common sense. Let's start with some, pointing us in the general direction kind of answers. Okay, so it says, what is the magnetic heading from Priest River to Shoshone? And when I look at the chart, Priest River is up here in the northwest, Shoshone is the southeast. So I'm not sure of the true heading yet or the magnetic heading yet. I might have an idea of the course, because like course would be like the path over the ground, whereas like true heading might be the actual heading the airplane flies in relation to true north, whereas like magnetic heading might be the magnetic heading that you have to fly in relationship to magnetic north. So there's a lot of different ways to measure this information. The first one we're going to try to figure out would be like true course. Like what's the actual TC, the actual course over the ground? And without doing anything complicated, I'm just looking at it, just by looking at it, okay? North is 360 straight up, east is 090 straight east, south would be 180 straight south. So just looking at this thing, it's basically, we're going to go southeast. That's just looking at it. And I'm thinking, southeast could be, here's like a VOR, which just happens to be on the screen anyway. So in this VOR, look at this particular problem has a lot of issues of magnetic variation. So when you remember these VORs are aligned with magnetic North Pole, which is different than the longitude line, which the longitude line is aligned with true North Pole. So true North Pole would be the longitude reference line. Magnetic North Pole would be this VOR. And if you notice the VOR, it has the big blue underneath my mouse that's pointing straight up to 0. I mean, that doesn't even look like it's pointing north. It almost looks like it's pointing northeast. So there's going to be a lot of variation, the difference of true north and magnetic north in this area. Just looking at it right here, and this might be the piece of the puzzle that you needed if you want me to shut up and move on to something else. But right here, if you notice this line, this dash magenta line, it says 14 degrees, 30 minutes east. So they're telling us just by looking at the picture that in this area, this is probably out, I don't know, somewhere in the Northwest, maybe like Utah or something. What you're seeing is that in that area, the magnetic North Pole has a large variation from the true North Pole. How large of a variation? It looks like 14.5 degrees, 14 degrees, 30 minutes, 30 seconds, something like that. So like 14.5 degrees, whether you call it 14 or 15. And if you're telling me that you're off by about 14 degrees, that might be the answer that you needed to hear. But if you want me to keep going, I'll walk you through the whole thing.
Yes,
So,
sir, if you wouldn't mind. Because
yeah.
I inputted all that information as well and still got 143.
Okay, so you're telling me 143, that's a southeasterly direction. So we're in the right ballpark. We think that we're going to be heading, you know, roughly on heading a 140, something in that ballpark to go southeast. Okay, I'm with you on that. Okay, so now that I've showed it to you on the screen, I'm going to go back to this foolish thing of trying to hold up my plotter to the screen, and I'm going to try to do my best to explain it to you and hold it up for you. So I'm lining up Priest River with my ruler. This is called a plotter. And then I'm trying to get that grommet, that centerpiece, to be perfectly on the line of longitude that runs north and south. And then I have a spinning wheel. So I'm going to spin my wheel so that way 360 or 0 goes straight north. And I got my line perfectly going through there. Now I'm just going to say this number out loud before I lose it, because it's going to be tricky once I put it down and try to put it in front of you. But it looks to me like I got a course, not magnetic, true course. I got a true course of 143. So I'm just going to make a note, TC 143. And I think to get from Priest River to Shoeshone, I think it's going to be about a 143, and I'm trying to hold it up, do my best for you. So what I'm going to try to really get in here. I can see Priest River at the top, yes, sir. And I'm trying to line that ruler, the edge of that ruler, up with Priest River. Here in the center, I got a grommet, and I'm trying to get that grommet as closely as lined with the line of longitude. And then down here at the bottom somewhere, and I can't really see my screen anymore, but at the bottom of the screen, I'm going to try to get my the edge of my ruler aligned with that Shoeshone airport.
Copy, yes, yet.
And then right there, because I have a rotating plotter, I'm trying to look where the line, the imaginary line, would go through, and it was pretty close to 143, but it may have shifted a bit since I picked it up and held it vertically.
Yes, sir.
Is this making sense, or is this confusing?
No, this is making perfect sense.
Okay, so you're with me now. We think that in a zero wind situation, using true north, we think that the correct course over the ground would be a course of 143.
Yes,
okay,
sir.
So now you would kind of go to, like for me, my instructions are written down here. Your instructions might be written up here or up here. Would you be interested in holding up your whiz wheel and showing me what yours looks like?
Yeah, absolutely. The instructions are up on the top, and then it doesn't really have anything much on the bottom or anything like that. It just has
I want to point it out to you. Are you ready?
Yes, sir.
Okay, you have a black area where it gives you instructions.
Yes, sir.
And then right beneath the black area is a silver area where it says the TC and all that.
Yes, sir.
That's what I'm looking at right there.
Yep. Oh, this
okay.
Right here? Or
I know.
You're talking about this right here.
That's
right?
it.
Yeah.
That's what I'm talking about. Okay, so now that you have an idea what we're doing, we're just going to follow some math. Okay. So it says, tell me your exact instruction. It says TC.
Says TC minus east or plus west variation equals magnetic course. I'm guessing that's MC.
Yep.
And then on the other side, it says, or next to it says MC minus left plus R equals WCA, which I'm guessing is wind correction angle.
You're on it.
And then equals MH, magnetic heading, I'm guessing. And
okay.
Then it's magnetic heading plus or minus deviation equals true or course heading.
Compass heading.
Compass heading. There we go.
Okay. So I just, very quickly wrote down your exact instructions that are on yours, so that way I can walk you through what yours says exactly. Okay. So we now have the true course. We think that the true course to get from Priest River to Shoshone is going to be 143. Okay. The next thing we're supposed to account for is variation. The line of variation could either be labeled as a W for west, or the line of variation could be labeled as an E for east. So if I go back to screen share and I show you this particular example, we have a variation underneath my mouse of 14 degrees, 30 minutes east. We can try to just keep it at 14.5. That works for me. If you wanted to be a person that rounded up or down, we could try some of that business as well. But I think, 14.5 would try to be good. So I'm going to try to type it on the screen so you can follow along, although I have a feeling that we're going to have to end up doing this a time or two. But let's just try to type it up there so we're all following along. And we think that we had a true course of, I don't know, should I really type all that stuff we just talked about? No, just keep moving. You got it. I got it. We talked about it. True course, we think the true course is 143. 143 degrees, okay? Now, we need to either plus or minus the variation. We think in this case, we have 14.5 degrees of east variation. Now, here's one of the biggest common things that people get confused. Everybody has heard the phrase. The phrase is east is least, west is best. And so the idea is that if it's an easterly variation, if it's labeled with an E, then we will subtract the number to give us a heading that'll be more to the left. If it's a westerly variation, then we will add the number, which will give us a heading more to the right. That is the correct answer. So just to make it clear, it does not matter what heading you cross the line of variation on. Like whether you cross that magenta variation line, I'll point it out again with my mouse, this variation line, it doesn't matter if you fly across that line on an east or a west heading. It doesn't matter. The math that you do for variation is all about whether the line is labeled east or west. It has nothing to do with whether you cross the line on an east or west heading. That's one of the most common errors I see with people doing this. So no matter what you're heading in that area, your compass is inaccurate in relation to true north because of magnetic variation. Okay, so we had a true course of 143, and we have a variation line labeled 14.5. So I'm going to go ahead and pull out my calculator, try to prevent myself from screwing up any math. We got 143, subtraction sign, 14.5. So I'll just write that out for you. We said 143, subtraction sign, 14.5. We'll call that variation. And I get an equal sign of 128.5. And I'm following the exact thing that you spoke to me. True course plus minus variation equals MC, magnetic course. So 128.5 is going to be our magnetic course. So if this was the day of the real test, you know, you might like really start reading the question and saying, what was the question asking? Was the question asking for magnetic course only? Because if that's the case, you're done. But if the question's asking for us to configure out like magnetic heading or compass heading, then we still have more math to do, such as wind correction angle, which I think is the case. So I think we need to do wind correction angle next. Is that correct?
Yes, sir.
All right, cool. So I'm going to document this on my paper because I know that once I click away from this, I'm going to lose the notes. So we think at this point we have a true course of 143. We think we have a variation of 14.5 east. And then we got a mag course of 128.5. Okay, so I'm going to go ahead and click away. It's going to get rid of our notes. I just know it's going to happen. Okay, now the next step, if we're following along on our instructions, is that we need to account for wind correction angle. So we did a little bit of this together the other day. We're going to walk ourselves through it again. I'm searching around for a pencil because a pen is not going to do the job. If you had a dry erase marker, some folks will do it that way. So I found myself a pencil, and last time we did this, I put a mark on my whiz wheel, and so that mark is still there. You can either erase it if you have an eraser. I've seen a lot of pilots like lick their finger. I think it's rub it off. Whatever you got to do to give yourself a clean slate, because you're going to want to be able to mark on the back of your whiz wheel. Okay. I promise I didn't make this up. This is old school right here. You just follow the instructions. Why don't you read me your instructions so it's not just me following my old-fashioned whiz wheel? What does your instruction say for step 1?
It says set wind direction under true index.
Okay, so I go back to the problem and I'm showing it to you. I don't know, maybe I'm overdoing this. So I'm just showing it to you. Now I'm showing it to you. It says that the wind is 030, 12 knots. It says our true airspeed is 95. So I need to just write that on this piece. That way I, keep track of all this information. We said wind is 030, 12 knots. And we said true airspeed is going to be 95 knots. So half the problem, with doing this is keeping all the information straight. Okay, so you told me that step 1 is to do the wind, and you said that we have something called true index where the triangle is, and we need to line up our wind. We said the wind is from 030, so I'm going to spin the wheel, and I spun it the wrong way. It doesn't really matter. It's just going to take me a minute to get there, and I'm going to line up my wind with 030. True index, 030. We're there. The next step is I need to make, did you read me all your steps? Where are you at so far?
The next step would be mark the wind velocity up to the center point.
Okay, so your center point is the grommet. You can use any reference number you want to. You could just use wherever it's at, and you could mark up, we said 12 knots, but a lot of pilots are going to try to make it easy on themselves. So they're going to try to line up that grommet with 100 just because it's a nice round number to work off of. So now that I got my grommet, my center hole lined up with 100, I need to make a mark that's up 12 knots. You can make any kind of mark you want. I've gotten to the point where I like to draw a nice plus sign or a cross, but if you'd rather draw a circle or a star or a triangle or whatever kind of mark you want, you just want it to be as accurate as possible to pinpoint the exact center of it. That's why I like a cross personally. So I'm going to find 12 knots up. And if you notice, between 110 and 120, there's, in my E6B, yours might be different. Mine has 3, 4, 5 boxes. So that means each box is worth 2 knots. So I've done my best job to make a nice clear mark. About 12 knots up. It's really kind of hard to see. Like if I start twisting it.
Yeah, I see it.
It's kind of, there's an X mark there I made.
Yes, sir.
Okay. So I'm putting it back. I'm on 030. Okay, what's the next step say on your whiz wheel?
It says set true course under true index.
Okay, we've already figured that out. We think our true course is 143. So here I had my true index set up to my index. Index is like a reference, big triangle.
Yes, sir.
So I had my triangle set up to 030. We're going to rotate. We're going to spin the wheel. It's everybody's favorite game, spin the wheel. And we're going to spin that sucker until we get to 143. And I'm pretty close. I mean, gosh, I don't know if I can really make it better than that. 143. I like it. So you can now get some information. You can see that mark that we made. The screen is kind of backwards when I look at it. When I look at it normal, it's to the left. So that wind mark, the pencil mark that we made, is to the left of the center grommet, and it's actually slightly behind us. So it's like that means our wind is going to be a slight left quartering tailwind. Probably more of a crosswind than anything. It's not directly behind us or in front of us, but it's kind of almost to our left and slightly behind. So we anticipate that this wind will be slightly pushing us faster. We'll get slightly a faster ground speed, slightly a bit of a tailwind, but it's really probably more of a crosswind than anything. And the crosswind is from the left. So what this is showing you is that triangle math. Here's a 10-degree line, and here's the center line that goes up and down. So that center, that X mark, looks to be about 7 degrees to the left. If each one of these boxes is worth 2, the center of that mark is maybe like 7 or 8. You just got to pick a number. I don't know. 7,
Yes, sir.
8.
Let's go. Yeah, 7.
So we think that for us to correct for the wind is coming at us from the left. So if we don't correct for the wind, then the wind is going to blow us. Since the wind is coming from the left, the wind is going to blow us from the left to the right, and we're going to end up off course too far to the right. So we have to account for that wind and plan on it, and we're going to have to angle our airplane, wind correction angle to the left slightly. But I don't want to get ahead of ourselves. Can you read me your instructions? Where are you at, one at a time? Where's our next step for our...
It's all right. We're number 4. It says slide wind velocity mark to true airspeed.
We are very close already. So if you notice that wind velocity mark, the cross, it's dang near at 95 anyway. But what you can do is you can slide this whole piece up and down.
Yes, sir.
And when you slide it up and down, you now can account for different aircraft that have different speeds, different power settings, if you're flying fast or slow, different variables. So now we're going to account for the fact that we have an airplane that has a true airspeed of 95 knots. So our instructions were to slide the wind velocity mark, the mark that we made, to 95. So I'm doing my best job to try to really put that cross, that pencil mark, at where I think it's going to be 95. And I think it's pretty dang close.
Yep, I think so too.
So what they're telling us is that if we get the wind velocity mark, the pencil mark on 95 knots, it's just like I said earlier, it's really looking like a crosswind from the left, and it looks like a bit of a tailwind. And so the grommet is going to be our ground speed, and we're actually anticipating that grommet, the hole in the center, it's showing us that we're going to have a ground speed of something more like 98, maybe even 99 knots. Even though our true airspeed's 95, the wind is pushing us. So over the ground, we might be getting more of a 98 or 99. In the real world, I'd probably use 98 just because, you know, I'd rather plan to go extra slow than plan to go extra fast. If I arrive early, it's usually not a big deal. But if I arrive late, then that means I end up flying longer, and then I end up burning extra fuel. And you never want to create a situation where you run out of gas.
Copy.
So what's our next step? I've kind of explained it all to you, but let's keep following our steps.
It says ground speed reads under center, which you already said it was about 98.
So I'm going to make that note right here, GS 98. So on my scratch pad, I just made a note. My ground speed is going to be 98 knots.
And then it says wind correction angle reads between center line and wind velocity mark. So that would be what, 8? degrees.
Yeah, but well, it looked like 8 earlier, but we've had a little bit of slide on, remember that? And
Yes,
so
sir.
now that we've slid up, ask yourself, is that mark still exactly at 8, or you think it's more of 7? You know, each one of those boxes is worth 2.
Mhm.
So it's kind of tricky. Do we think it's worth 7 or 8? You just got to pick one. I don't know. Maybe
Okay.
7.5.
Yeah, let's go 7.5.
Let's try a 7.5. Okay. So we think wind correction angle is it left or right?
It's to the left, so you would have to subtract.
Good. So our wind correction angle is going to be a subtract 7.5 degrees. And again, I just make that small note here on my piece of paper, WCA minus 7.5, so that way I can keep track of all this information that we're doing. Was there any more instructions, or was that everything?
That is, it says wind correction angle reads between center line and velocity mark. Yeah, that's it. Wind
Okay.
velocity mark.
We are very, very close. So now let us go back to our screen share and let's go back to your instructions. Remember your instructions that you read that was in the silver part?
Yes, sir.
Okay, so we already did some of them, but unfortunately, let's just kind of start from the top to keep it nice and straight. What are your instructions from the beginning? You said true course, plus minus variation. So we said our
Yes, sir.
true course today was 143. And then we need to plus minus the variation. Today, we said that was variation was what? 14.5 east?
14.5 east, which gives us, I believe, 128.5.
So then we're at, you called it 128.5, and you called that your magnetic course.
Yes, sir.
Okay, and our next step was to do what?
You would add or subtract your magnetic course, whether it's left, you subtract left, and if it's the right, you add it, and that's your wind correction angle, which gives you your magnetic heading.
Okay, so we said today our wind correction angle is minus 7.5.
Yes,
so
sir.
we're going to say minus 7.5, and that's to the left wind correction angle. So again, just, you know, if you use your calculator, it's tough to screw it up too much, but it looks like 121.
Mm-hmm.
I agree. So we think 121 is now our magnetic heading. Do you agree?
Yes, sir.
And then I think that's all this we can do for this particular problem. 121. Now, if you had a compass card in front of you and you could see the deviation, the amount of compass deviation between that particular cockpit and that particular compass, we could do additional math to figure out compass heading. If I remember, though, I think that this is about all we can do for this particular problem. So just for kicks, let's look at our possible answers. I'm going to figure this out. Come on. There it is. Okay, so what is the magnetic heading for a flight from Priest River 1 to Shoshone County Airport? The wind is 03012 knots, true airspeed is 95 knots. And they say the correct answer is 118. We are currently getting an answer of 121. We're only 3 degrees off. That ain't bad. I think that some of it might have to do with rounding and like how accurate you can really make that pencil point.
Of course.
So there were some times we did a 0.5 here or there. We rounded up or down. But I mean, we're in the ballpark, 121, 118. Could be a lot worse.
That makes sense, though. Just like, so you, at that point, you just go with pretty much the closest number to your number.
Yeah, because I mean, you know, unfortunately, the person who created this problem, they might have had some super accurate computer software that, you know, did it way more accurate than your hand and your pencil mark could ever make it.
Yes,
or
sir.
maybe vice versa. They did it with pencil and paper and their pencil mark was way less accurate than yours. You know, we don't really know. Maybe they rounded up, maybe they rounded down. I mean, there's just, it's not perfect, unfortunately. And that's why you could literally spend, you know, I mean, like we've probably spent over half an hour just on one problem there. And you could literally spend a whole hour, if not even longer, on some of these problems and still not get the answer that the FAA says. But hopefully you're getting something in the ballpark.
Yes, sir. I'm looking at the question from the original question that I gave you, and the answer is 121. So we actually got it right.
Oh, so the FAA has updated their database, updated their questions, and we're actually looking at an old possible answer choices here?
I believe so. Yeah, it says 121 is the correct answer, which to me actually made sense. So I know where I messed up at, where I got 143 was because when I originally did my the plotter, I got 160 instead of 140. So I had added 20 more, which that right there makes perfect sense on why I got it wrong.
From here, what I would say is, since we're already so deep into this problem, if you wanted me to explain to you a little bit more, like such as time, speed, distance math, I could show you some time, speed, distance math using the same setup since we're already so deep in this problem. Or
Yeah.
if there was a different question that you'd rather address, then we can shift gears and go for something else.
No, we can do a distance and that kind of problem. There's other questions I want to talk about too, but we could save those for Monday if that's all right.
It's whatever you want to do.
Okay.
If you want to do a time, speed, distance, we're already so deep in it, it might make sense. But if you have a question that's burning, by all means, we can do that too.
No, let's do a time distance.
Okay, so what I want to show you with the time, speed, distance math, like let's say we've already done all this math. We have an idea that our ground speed, I documented it here, we have an idea that our ground speed is going to be 98 knots. So you could have a different question that would ask, how long will the flight take? How long will this flight take? And you already did all this math, and now the next step is to figure out how long it's going to take. In the real world, if you have a real sectional chart in front of you, then you would just use your plotter and it would have a scale, and all the scale numbers would tell you, like the ruler would tell you how many miles. And in the real world, you would just, you know, put your plotter up there and you would measure the scale and you'd be able to see how many miles distance is between the two airports. Really quick and really easy. A few things to be careful about. One side of the plotter is for statute miles. You flip it over, the other side of the plotter is for nautical miles. So that can throw off your math. In the real world, that can throw off your math. Make sure that you're using the appropriate scale. For us, flying a Cirrus SR-20 or a Piper Seminole, we have a newer technology that uses nautical miles and knots. If you fly an antique airplane, some of the older airplanes, they have a airspeed indicator that does miles per hour, and their math might be based off of statute miles instead of nautical miles. So you want to make sure that you're using the correct side of the ruler in the real world on the real sectional chart. With that said, this is not the real world. This is the FAA test. So one of the big issues that you're going to be fighting is the scale. Fighting the scale? What do you mean? Well, I'm glad you asked. So what I want to show you here is that when you see, I can do this on the screen share. So when you look at, thought I could. Yeah, okay. When you're taking the test, you see the words, no, this chart is not to scale. So all of a sudden, you have to use the associated scale. So all of a sudden, if you try to use your plotter to measure the distance, it's not to the correct scale and it won't work. So you would never do this in the real world, but for the sake of the test, you have to use the scale up top here where my mouse is. See, it says nautical miles. So this amount of distance is worth 10 nautical miles. This amount of distance will be worth 20 and then 30. And then over here on the left, they're showing you each particular box how much 1 mile would be worth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are you seeing the scale? Is that making sense?
Yes, sir.
Okay. So what you have to do, or what I would do if I was tackling this problem, I'll do my best job to show you here. I line up a piece of paper, just a scratch piece of paper, and I line up a corner of my scratch piece of paper with my top airport, which is called Priest Sandpoint? No, Priest River. So I line up the top corner of my scratch paper with Priest River Airport. And then on the bottom of my paper, I'm going to make a mark where I intersect with the center of Shoshone Airport. And I'm going to try to hold it up here. If it gets off, it gets off. But the idea is that I got the top corner of my piece of paper lined up with the Priest River Airport.
Yes, sir.
And then the bottom of my piece of paper, I've made a dark mark where the Shoshone Airport lives.
Oh, okay. So all you're gonna do is just put the corner of that up against the ruling on top.
Yep. So now I'm going to make the mark and I'll show it to you. I'm going to use the corner of my piece of paper. Dang it, breaking my lead. And you can see here what I'm starting to do. I'm starting to line up the corner with the 0 for nautical miles, and I made the 10 mark, the 20 mark, and the 30 mark. But I still have more distance to go till I get to my airport, so I need to keep working with that scale.
Copy.
So that's how I use my scale to get to 49 miles. Is this confusing? Is this making sense?
No, it's making perfect sense, sir.
Okay, so now we've figured out the information of how many miles between Priest River Airport and Shoshone Airport. We know that it's 49 miles. So again, this question didn't ask it, but you have other questions on the written exam that might ask, what's the amount of time? So time is based on a 60 scale. We got to go from known to unknown. We know, because we've done all this math, that we're going to be traveling about a ground speed of 98 knots. So that's a ratio of 98 nautical miles for every 60 minutes. So we have our 60, which is our big triangle. Time is always on the inner. Time is always on the inner. So I got 55, this big triangle, 60. I need to set up the ratio. Once you set up the ratio, move your eyes, not the wheel. Time is always on the inner. What ratio do I want to set up? I want to set up 60 minutes on the inner to correlate to 98 miles on the outer. So right now, my ratio is set up for 60 minutes on the inner, 114 on the outer. We'll call that 140. So I need to spin the wheel, and I need to lube it up or something. I can barely get the spin. Oh, it's going. I'm getting it. And so I got a 10 and I got a 90 here. So I need to try to set up 98. And I think that's pretty dang close, to be honest.
Yeah, that looks pretty close.
So I've established a ratio of 60 minutes on the inner to be 98 nautical miles on the outer. So now that the ratio is set, move your eyes, not the wheel. So on the outer, I've established that if I want to go 98 miles on the outer, it's going to take me 60 minutes on the inner. But wait a minute, I'm not going 98 miles. I'm trying to go, I'm sure I documented it somewhere. Oh, on my piece of paper here. I'm trying to go 49 miles. So on the outer, I'm just kind of spinning my wheel around to try to find 49. And I'm thinking I'm right in there somewhere.
Would it be 30 minutes?
It looks like 30 minutes to me, don't you?
Yeah.
All right. So if the question asked how many minutes, now we know how to find the answer of how many minutes. 30 minutes.
Copy.
The last question that could come from this would be, how much fuel would you burn?
Yes, that's the one I was going to ask next.
So we're just making up numbers just to show you the math. So why don't you just give me a number? How much fuel do you think this airplane is going to burn an hour?
Let's go with 11.2.
So if this airplane was burning 11.2 gallons per hour, and I'm just documenting this on paper, and we said 30 minutes. Okay, so I just documented some quick, dirty information. We said 30 minutes, we said 11.2 gallons per hour. Now we need to set up a new ratio. Remember, time is always on the inner. Time is always on the inner. What's the ratio? We go from known to unknown. What is known? We have a airplane that's burning 11.2 gallons per hour. What does that ratio mean? It means 60 minutes, we're going to burn 11.2 gallons. So right now we got a ratio set up for 60 minutes, only burning like 9.8 gallons. So we need to spin the wheel. Oh my gosh, I need lube. I'm so close. That's pretty good. Okay, so now I've established a ratio with the slide ruler, the whiz wheel, and it's established that in 60 minutes, time is always on the inner, I will burn 11.2 gallons on the outer. But I don't care. Once the ratio is set, move your eyes, not the wheel. So in this case, we want to know about 30 minutes. If we're going to go flying for 30 minutes on the inner, how much fuel are we going to burn on the outer?
Is it 5.6?
That would be the correct answer.
I like this wheel.
Yeah. So again, this particular problem on the written exam did not ask for all that information, but there are going to be some problems that do ask for all this information, and it's effing time consuming, you know?
Yeah.
Like you can literally spend an hour, if not more, if you screw up the math somewhere along the way and have to redo it. I mean, you could spend an hour, 45 minutes easy just trying to answer one problem. And that one ABC multiple guess problem is worth the same as all the others. So when you see these tricky questions come up, you skip them and you come back to them at the end because you don't want to burn up all your brain power and time too soon.
Copy. That makes a lot of sense. You actually covered a lot of questions, so I greatly appreciate it.
Yeah, but you know, you told me you had other questions. If you'd like to launch into a new question, I'm happy to do so. If you're trying to, you know, do something else with your day and you want to head out, that's fine as well. But I mean, I'm here to help you if you got other questions.
Yeah, it's 11:42 if or 11:32 or 11:34. It's not that big of a deal. Let me see if I can find some other ones.
Okay. I'm going to hit the button that says pause recording. I usually don't do this, but let me just hit it. Do you want to stop recording? If yes, you'll receive an email notification when the recording's ready. Okay, that's fine.